Hello and welcome to the Walking Talking Topic multi-mark week 4 selection of questions, and we're going to start with question number 1, and I'm Mr. Barton. So let's have a look at this one here. The volume of the triangular prism is 120 centimeters cubed. Explain and show through working how you know that the cross section of the triangular prism, so that triangle there, is an isosceles triangle. Now, whenever it says explain, students tend to struggle, but I think we're going to be okay with this. Let's just take our time and see what we know. So the volume is 120, so let's get that down first. Volume equals 120 centimeters cubed. Now, it's a prism, so hopefully that you also know that the volume is the area of the cross-section, or the area of the face, some people say, times by the length, or kind of how far back you go. So it's the area of that face there, the triangle, times by how far back that face goes. So we know that our 120 is going to be equal to this area, I don't know what that is yet, times by my length, how far back it goes, which is 10. Well, I think we can see there that that's going to tell us that the cross-section, the only thing that can be, is going to be 120 divided by 10, which equals 12 centimeters squared. So my triangle must have an area of 12 centimeters squared. So let's have a little think about this. There's my triangle there, and I can see it's got a height of 4 centimeters. What's an area of a triangle? So the area of a triangle is base times height divided by 2. And I know that the answer to that has got to be 12. So I don't know what my base is. Don't know yet. That base bit there. Don't know what that is. But I know what my height is. It's kindly marked it on for me. It's 4. So my base times by my height, so times by 4, divided by 2 has got to equal 12, because I know my area of my triangle is already 12. Let's solve this equation. Let's times both sides by 2. So I get b times by 4 is equal to 24. And then let's divide by 4. So I get b equals 6 centimeters. So I've got a base there of 6 centimeters. Now the problem is that still doesn't tell me it's isosceles, but I'll tell you what, I'm honing right in on the answer. That bit there, that part there of the triangle is 5. So let's just take this bit of the triangle here. 5 there, and I've got 4 there. And you can see that they've marked a right angle in for me there. Now this is the key bit of the question. How would I work out that side of the triangle? Well, I've got a right angled triangle, I've got a hypotenuse, and I've got one of the shorter sides. So that bit there, let's call him x, is going to be equal to my hypotenuse squared, take away my shorter side squared, and square root my answer. Now that's going to be 25, take away 16, square root my answer, which I think is going to come to the square root of 9, which is 3. So now what have I got here? I've got that side there is 3. So let's just do the examiner a little drawing here, just to convince them that I know what I'm doing. So I've got myself a triangle. I know that's 4, that's 5, that's 3. I know my whole base across is 6, so that's got to be 3 as well. And before you know it, if I've got a 3 and a 4 and a 5 there, I've got to have a 3 and a 4 and a 5 there. Therefore, my triangle is isosceles. And I've shown very clearly that I've got that from the area of the face, then I've worked out the base, and I might just, let's just call that base. I mean, I've got it labelled there, but I might as well really emphasise it. Therefore, I've also worked out what this kind of bottom bit is here. That's 3, that's 3, the whole thing's 6, so therefore my triangle must be isosceles. A lovely question that. I had a really good time doing that one.